Hello everyone, so today we're going to be building the tubular quad. So I've made a lot of videos about this quad. This is a custom quad with tubular hollow arms designed and built by me without any CNC or anything like that. So today I'm going to be going over how to build this thing with tools that aren't a CNC basically. So the new quad that I'm going to be building has a few design changes, the main one being that the fuselage is going to be 10 millimeters longer so that the camera gets more of the motors out of view. If you want to build this yourself, all of the CAD files and drawings are up and they are free to access to everyone. They're public. I made a video in the past about that, so I will put the link to that video, which also has the link to the files, in the description below. Before we get started, I want to say working with carbon is really nasty. The carbon particles can get stuck in your lungs, they can get in your eyes and things like that. So always use at least breathing protection. I use eye protection as well because these particles are really nasty and your body actually can't recognize that they're there, so they just stay there forever, unlike things that are biosoluble like wood. Just make sure you're taking the proper safety precautions. Don't mess around with the carbon dust because it is pretty nasty. So let's go ahead and get into the build. So the first thing that I've done is I printed out the drawings. So these are just the inventor drawing files, and I just printed it straight from that file. And they're all drawn at 1:1 scale, so when you print them out, they should be exactly the right dimensions. So I just go ahead and double check, and they are correct. So I have 4 arms printed, I have the mid plate, I have the bottom plate, and I have the top plate. So if you're printing these from Inventor, when you print, there's a little box you want to check that says remove line widths, and that just helps with the edges of things. So like when we're going to be cutting out say the mid plate, okay, it thins up these lines around the edges so that we can get a more exact dimension when we are sanding down to the line. So it's not completely necessary, but it helps out a little bit. The critical thing is just the hole locations, and I think those are all thin lines in all of the files, including the PDFs and whatnot. But it is useful to have all the lines be thin so that the edges of your carbon pieces are exact as well. So the first thing that we have to do is actually do some epoxy resin work, because there's not readily available carbon tube that is 8 millimeters inner diameter and 12 millimeters outer diameter unless you get it from China and wait for like a month for it to get here. So what I do is I actually just epoxy a little carbon tube and a big carbon tube, and they're both 1 millimeter walls, and then that gives me a 2 millimeter wall carbon tube. So we're going to do that, and I also am going to use only 1.5 millimeter carbon plate, and the bottom plate is 3 millimeters, so I'm actually going to cut some pieces of this out and then epoxy 2 of these together to give me 3 millimeter carbon plate. So let's go do that. Okay, so now that we have all our pieces cut out, we're going to go ahead and glue the small tubes inside the bigger tubes, and then glue these two plates together to make our bottom plate. So I'm just going to sand the little tubes and sand the mating sides of these two plates so that I get good adhesion with the laminating resin I'm going to use here. You can also just use normal epoxy, but I find the thinner laminating resin is a little easier to work with for this application, but either work just fine. It'll be plenty strong. Okay, so while we're waiting for the epoxy to cure, let's go ahead and cut out the rest of the carbon we need for the mid plate and then the 4 plates for the motor mounts that are going to attach to the tube arms. Okay, so now I'm going to cut out all of the flat pieces of carbon. So I'm actually only going to show the top plate for this because it shows a little bit of everything, and that way this video isn't too long. The next set of steps we're going to do is we're going to glue the paper to the carbon with just a glue stick works fine, or you can use spray adhesive. And then we're going to mark the center of the holes. Then we're going to drill a pilot hole in the center of the holes, and then we're going to actually drill the correct size 3mm hole. And the reason why we do it in so many steps is to get it as accurate as possible, because the hole locations are the most critical part to these pieces, because like the edges and stuff aren't super critical to how everything lines up, but the hole locations are. So that's why we're going to be extra careful with that. And then to make these slots, I'm just going to drill a series of holes and then file the edges straight. So I'm actually going to wait to clean up these slots right here because the template's kind of torn up, so I can't really see where the line is. So I'm going to do that after I take the template off. So right now what we're going to do is we're going to sand down to the line on the edges to get our final shape, and then to cut this notch here I'll just use a combination of the Dremel and files, and then of course I will go ahead and clean these up after I pull the template off. Okay, so I have all of the flat carbon pieces cut out. We have the bottom plate, top plate, the mid plate, and the 4 motor mounts that are going to attach to the tubes. And now we're going to do what I'm anticipating to be the hardest part of this build, which is drilling the holes in the tubes, because we're going to be drilling along, you know, a circle instead of a flat piece. So what I'm going to do is pretty much the same thing as for the flat pieces. I'm going to cut the template out, glue it on the arms as straight as I can, then mark the centers of the holes, drill pilot holes, and then drill the full-size 3mm holes. And what I'm going to do is I'm going to put the tube in the drill press vise, and then I'm going to do all the drilling so that all 4 holes are drilled without moving the tube, so that at least I know that all the holes will be straight up and down, and hopefully they will all end up in a line as well. So let's get to it, and hopefully everything lines up at the end. Okay, so now that I've drilled the holes in the arms more or less straight, there's a couple more things to do to the arms. So first I obviously have to sand them to length, and then I'm going to cut a notch at the end where the motor mount goes, right here, for the wires to pass through, so that the end of the arm is what impacts first, instead of having the arm basically shear your wires in a crash. And then at the other end, I have to make room for the wires to pass out of the tubes so they can be soldered to the 4-in-1 ESC. And previously I did this, and this is how it is in the plans, is I just 45'd the corners of the tubes. But this actually creates a stress riser because so much material is taken off. So I'm actually going to try to slot it out sideways like this and leave a little more meat around the screw hole, because the one arm that I broke, that's where it broke, is right here, because that material was a little too thin. Okay, so now that we are finally done cutting out all of the carbon, we can actually start assembling this. So what we're going to do first is make the arm sandwich with the bottom plate, the arms, and the mid plate, so that we can mount the motor mounts to the arms and make sure they're nice and straight. So what we're going to do is we're going to use 18mm bolts going through the bottom of the bottom plate, through the arms, into the mid plate, and then we're going to have in the 4 inner holes the M3 nuts, and the 4 outer holes the standoffs, and these are vibration isolating standoffs, and those are going to be what the flight controller mounts to. Okay, so I've got most of this assembled now, and you may have noticed that I had a little trouble getting one of the arms on, and that's because the holes in the arms were a little bit too close together, so I basically turned them a little bit into a slot instead of a hole to get it to fit, and that's fine. That's kind of to be expected since we are doing all this by hand. And you may have also noticed that I labeled the arms with Sharpie, because once again, this is made by hand, so everything's not going to be so precise that it's necessarily going to fit back together perfectly if I had swapped all the arms around. The next thing to do is to attach these motor mounts to the ends of the arms. So you can see I'm using some screws to line the holes up, and I'm going to put the quad upside down on 4 blocks of foam just because I know they're all equal heights, and then I'm going to actually tack them in place, pull the screws out, and then glue them down the rest of the way. And I'm actually going to try using this really thin CA. I would normally use epoxy, but I found that this CA is actually really strong compared to a lot of other CAs that I've used, so I'm going to give this a shot this time, but you can use epoxy as well. That works just fine. Okay, so now that the motor mounts are attached, the only things left to do are to attach the standoffs and the top plate. So there's 4 standoffs, and then in the bottom plate there are 8mm long screws, and in the top plate there are 6mm long screws. And then after that we will be finished. Okay, so we are finally done putting this thing together. I know some of you guys are going to be wondering this, so I weighed this, as you see it here, plus the 8 motor mount screws, and it is 130 grams, which is a little on the heavy side, but it is a 6-inch frame, and it's really beefy with the 2mm thick tubes, the 3mm bottom plate, and also considering that we didn't have access to a CNC or anything, we can't do any kind of lightning holes. I mean, we could, but it's really not worth the effort in my opinion. So with those things in mind, I think this is a pretty good weight. I'll probably be posting a time lapse or something of putting all the electronics in this. I'm just going to take them out of my old quad, so I don't think it's really worth doing a complete tutorial on that because pretty much everything's already soldered up. So I'll just do like a narrated time lapse of that. I think that is it for this video. So let me know down in the comments any improvements you think could be made to this frame design. Please like this video if you liked it, and please get subscribed to see more content like this in the future. Thanks for watching.